This is going to start the lesson on basically how derivatives tie into graph behavior. And we're going to look at some topics called intervals of increase and intervals of decrease, maximums, minimums. Together, these are called extrema, the extremes. That's kind of plural for the extremes. And kind of a weird one called a point of inflection. Sometimes there's an X there. So today's lesson, what you're watching right now, I just want to get at the concepts. We're not going to do sample problems. That will be a future video. I just want to get at what's going on here. So remember, the core idea underneath everything we're going to do for this whole unit, this is going to be like several days of lessons, is the derivative is the slope of the tangent line to a curve at some particular spot. Now let's look at that. Right now we are not thinking about computing derivatives, we're thinking about that aspect of derivatives. So don't think derivative, think tangent line and think about its slope. So see how that's like a big positive slope, like maybe it's m equals 2. And then later on in the curve, that's still positive, but not as steep. Maybe that's like m equals 1.5. And this is a positive slope here, but it's getting less and less steep. Now look what happens as I get to the peak. It levels off. That is very important. At maximums and minimums, the first derivative is 0. Well, that's one possibility. But do you see that? Now, as I start to go off of that peak, see how the slopes start becoming negative? And then when I hit kind of this midpoint, that's the most negative it gets. And then I start changing like this, and it's going back to 0 at that valley. And then I'm going to start increasing, and now I have positive slopes. And at some point I hit maximum positive slope. And then it starts to change and go down, like it's not as steep. That point where it changes from getting steeper to getting less steep, that is called a point of inflection, kind of like think of flexing. So then it's getting less steep, and see, it's 0 there. Now look, this is a minimum value. See it right there? That's called a cusp, that shape. As I head down towards it, that is a minimum, but this time the slope of the tangent line would be undefined. So what I just found is, let's write this down. The maximums and minimums occur when the derivative is 0 or when the first derivative is undefined, right? So that's a really important thing. Now, when I have an equation, I can I can find the derivative, so I got y prime equals whatever, and all I got to do is set that equal to 0, and that's going to be my peaks and my valleys, my maximums and minimums. And this is going to walk us into a very important aspect of calculus called optimization, right? Think about, when do you want to know when something is at its highest point or at its lowest point? All the time. Like you could be talking about like profit or loss. You could be talking about the aerodynamics of a vehicle. You're looking at when something is the most or the least. This is a hugely important part of calculus, right? So I want you to see how that kind of plays out. And I want to talk about what's going on besides the peaks and valleys a little bit more. Do you see how this whole chunk of the curve up to that point? Here, let's label it. See that point right there? That's a maximum. I'm going to say, like, let's say that's happening at x equals a. And then here, that's a minimum. Let's say that's x equals b. And this would be some value at that maximum. Let's call that c. And this would be d. And there aren't any more. And we'll deal with points of inflection at a later point in time. I just wanted to bring up their existence to you right now. We'll get more specific later. So we'll talk about that later. Today we're going to focus on these two. So, right, maybe this is 1, and this is 10, and 15, and 20. Right? These would be some numbers, but I don't know what they are, so I'm just giving them a temporary letter for a name. Everywhere before that peak, the slopes are positive. And furthermore, when I go left to right, so intervals of increase and decrease. So when you're doing those, you're going left to right. So if I start over here, notice that all of these slopes are positive until I hit that peak. If they're positive, if the slopes are positive, then the derivative is positive. This is, imagine yourself on a mountain. And you're always walking left to right. So this is I'm going up, right? This is called an interval of increase. Because I'm going up the whole time until I hit that maximum. Then I start going down. That is called decreasing. So this right here, from A to B, that is an interval of decrease. Then I start going up again from B to C. That is an interval of increase. And then I start going down again. So from here to here, this is an interval of decrease. And then from here forever onwards, I'm going up. So that's an interval of increase. This is a maximum. This is a minimum. This is a maximum. This is a minimum. And I'm going to throw one more little bit of language at you. Absolute or global versus local. Oh, I'm blanking out on the other way to say local. Relative. Relative or local. Now think of a mountain chain. See, these would be peaks in the mountain chain. These are both high points, right? You could look around, see all around you. But that is the highest point. It makes sense that we would have a way to say, well, you got your high points and then you got your highest point. And the language is this. Absolute or local is the highest or lowest. Whereas relative or lower means a highest or lowest. A high or low, let's call it that. Right? So let's just use absolute and relative. But depending on what textbook you look at, you might see those. This is an absolute, well, it's not. Because I wanted to say this was the highest peak, but do you see how this arrow goes up? This actually doesn't go up forever, so I'm going to cut this off. I got to change this. I'm sorry. Let's put it so that this just stops right here. Let's call that at point E. So this would be the absolute maximum, because there is no higher point on the whole curve than that point. This is a high point, so it's a relative maximum. This is also a high point, so it is now a relative maximum. There wasn't one there when it was going up forever. A maximum is a place where you stop going up. That's a maximum. So when I cut it off there, that became a maximum. This one doesn't have an absolute minimum because the bottom drops out. But this is a low point, a relative minimum, and this is a low point, a relative minimum. So see, I'm going to have to get to the point where I start creating a list here, like how do I actually say it? But step one is visualizing it. This is an interval of increase. This is an interval of increase. This is an interval of increase. This is an interval of decrease. This is an interval of decrease. And the rest are specifically maxes or mins. So that's important. It's not difficult, but you just got to be able to, you got to know the language and what you're looking for. Now, let's start writing. How would I list these out? How do I want you to list these out, like on a test, let's say? So the way I would like things set up is we're going to have two lists. We're going to have intervals of increase or decrease. And then for now, I'm going to call them let's call them extrema. But very shortly, so that's maxes and mins. We're going to expand that and call it critical points because critical points can include something we're not dealing with in the picture, and that's those points of inflection. We'll worry about those later. So we want to make two lists. Let's start with the more obvious ones, the extrema. So I see a maximum here. It's right there. So I could say at x equals a, there is an absolute max. Now, well, let's just keep going. There's a minimum here at x equals b. So at x equals b, there's a relative minimum. Then here I see a relative max. So at x equals c, there's a relative maximum. Then here I see a minimum. So that's at r equals d, there's a relative minimum. And then at this endpoint, at x equals e, I have a relative maximum. And that's everything. So there's my list. Now, after we finish our list, I'm going to erase these letters and put numbers in there in case this is confusing, right? You don't like seeing all those letters. But let's just do what's in the picture for now. Now, the intervals of increase and decrease. So from this goes all the way back, going forever back up to A, it is increasing. So there's two ways you can put this. I could say, I could put from minus infinity to A, and I'm not going to put or equals because that's an interval of increase, right? So if you want, you could just put increase because we already labeled it as intervals. So I'm not going to put or equals because this is specifically when the first derivative is positive, it is increasing. At that specific point, it is 0. It is not positive. So we are not going to include that endpoint. Then from A to B, it is going down the whole time. From A to B, it is decreasing. From B to C, it is increasing. I'm going to run out of room. I was trying to space those out so they're a little more visually distinctive, but I need the space. And then from D to E, oh sorry, I skipped one. From C to D, it's decreasing. And then from D to E, it is increasing. Now, today, it's alternating, increase, right? But later on, when we do points of inflection, you might get a couple increasings back to back. So for now, They're alternating, but don't go crazy with seeing that pattern. So this would be like the answer. Like if I asked the question, list all intervals of increase and decrease, and list all the extrema. I'm going to expand on this later, but let's put some numbers in. But because that's kind of distasteful and it doesn't feel like a normal problem, what if this was at 1 and this was at 5 and that's 9? Let's call that 14 and we'll call this 22, right? So let's say that's those x values. Then that would change the problem as follows. From minus infinity up to 1, I'm increasing. From 1 to 5, I'm decreasing. From 5 to 9, I'm increasing. From 9 to 14, I'm decreasing. And from 14 to 22, I'm increasing. Furthermore, at x equals 1, there's an absolute max. At x equals 5, there's a relative min. At x equals 9, relative max. At x equals 14, relative min. And at x equals 22, relative max. Right? So that probably looks a little more normal. And that's what we're looking for. So we have our graph. We're picking these things off. Hopefully this is very clear to you. What the next video is going to be is we are going to just start with our first equation and do the whole thing from scratch. This is the underlying concept. So hopefully that's kind of clear what we're doing right here. Let's tie it up there, and our next lesson will be our first example.